topic phase change material.
This call is now being recorded.
Sir, I'm Segar, sir.
Yeah.
Sir, let me first introduce you to the participants, sir.
Okay.
Good morning, participants. Welcome you all for the last day of 5 days FDP sponsored by Plus Advanced Technology. This is the last day of the 5 days program. Today we have with us Dr. Sudhir Pathak, who is working in Plus Advanced Technology, who is going to deliver a session on just a minute, sir.
Yeah.
Let me admit some persons in the group, sir.
Okay.
So thank you all for joining. So today we have Sudhir Pathak, sir, Dr. Sudhir Pathak, sir, from Plus Advanced Technology, who is going to deliver a session on energy efficiency in cold room and building applications on behalf of Murugappa Polytechnic College and on behalf of the Department of Mechanical Engineering. We extend our heartiest welcome to Dr. Sudhir Pathak, and I invite all the participants to patiently listen his session. So this is going to be a very informative session. I request Dr. Sudhir Pathak to take over the session, sir. Welcome, sir.
Okay. Thank you, sir.
Thanks, sir.
So my presentation is visible to sir. Hello.
Yes, sir. Now it is visible, sir.
Yeah. Is it visible to everyone? Yeah. Okay. I'm just turning off my camera, sir, just due to increasing the bandwidth of internet. Is it okay with you? Or
Sir?
I'm just turning off my camera to increasing the bandwidth of internet. So is it okay with you?
Yes, sir. No issues.
Okay.
So participants, please switch off your camera. The connectivity will be okay. When we ask to, you can on your camera. Thank you.
Okay. So once again, very good morning. I am Dr. Sudhir, a research scientist in Plus Advanced Technologies. And before starting today's session, I'm just recapping the previous sessions in which my colleagues covered the various topics, like they introduced the phase change materials and how can we use the phase change materials in different applications. After that, they have covered the application of phase change material in pharmaceutical industry and application of phase change material in pharma, foods and agriculture industry. And today I'm going to cover the topic, sir already mentioned about it, the application of phase change material in cold rooms, or we can say in refrigeration industry and building industry. So today's topic is mass effect concept, which is a passive thermal management solution. And here I'm going to discuss about how can we integrate, how can we use the phase change materials in refrigeration systems like chest freezers, cold rooms, and how can we integrate or use the phase change materials in building applications for better thermal management, like in space heating or cooling applications. So the content of today's session is like, first we understand the concept of mass effect, then we understand the significance of mass effect in refrigeration. Then we covered the various types of fashion materials and their temperature range. Then we discuss about the innovation in technology. How can we integrate the PCM which is filled in taps, or how can we integrate the PCM which is filled in pouches? After that, we covered the application part like PCM integration in chest freezers, PCM integration in cold rooms, PCM integration in buildings. After that, we will understand a case study where we have integrated the fission material with a chest freezer and calculate how can we get the energy efficiency and cost savings by implementing the fission material in chest freezer. First, we will discuss or understand the mass effect concept, which is a thermal inertia. Generally, the mass effect concept is particularly in the context of refrigeration refers to the efficiency of heat absorption and cooling performance in systems like cold room and chest freezer. Mass effect is nothing, it is just the effect of inertia where we have placed extra energy, we put the extra energy or we store the extra energy that will help to regulate the temperature whenever.
Sir,
Right, yeah,
can you go for the presentation mode, sir?
yeah, sure.
And the slide, the screen size is less, sir. If you go for
Yeah, okay.
Thank you, sir.
Okay. So then this extra stored energy can be released at the time of need, and this property maintain the stable indoor temperature. Also, we are going to understand how can we implement the fashion material in energy efficiency and getting the cost savings and the innovative solutions we obtained by using the fashion materials. Like I'm giving one of the example, if we place our food products or any other product in the cold room and suddenly there is a power outage or due to ambient conditions, the temperature is suddenly fluctuating. So, or the inside temperature of the cold room is also gets increased with respect to the time. And if our product maintenance range is somewhere in between 19 to 18 degrees centigrade, and after some time the range will increase, so our product will, we can say, lose its integrity, or we can say it will not intact like the previous one. So we have to maintain that temperature limit to for the preservation or for the integrity of that product. So in that time we can use the phase change material. It will give you the extra heat cooling effect. So or that extra temperature rise is generally called exertion effect. Excursion effect. And if we decrease the temperature limit from the that particular range, like minus 19 to 18, then again our product get deformed, or we can say it lose its integrity. So we have to maintain a fixed temperature range. If we use that certain temperature range PCM in the cold room, so whenever we face the power outages, that PCM release that extra cold and maintain the stable temperature inside the cold room, and that effect generally known as mass effect concept. Next, how it works in cold rooms. Suppose we have placed the PCM in form of blocks or in form of filled tabs or in form of pouches, like as shown in this figure, and the product is placed. So whenever the temperature is rises, the heat moves upward by natural convection, which is absorbed by the PCM modules, which are placed at the top. And PCM, by absorbing this heat, releases its cold energy to that ambient or that extra space. So that will maintain the temperature. That's how PCM will work. And one more point is here, if you say how the PCM charge or store that cold energy, whenever there is a continuous operation of refrigeration, PCM absorbs with respect to time some extra cold energy and gets freezed. Whenever we face the power outages or whenever we face the temperature fluctuation in the cold room, then it will deliver its energy and maintain the stable temperature. So that's how we can increase the efficiency. That's how we can increase the uh, backup hours of that cold room when we implement the phase change material. So it is a very good option for the rural regions where electricity fluctuations are very high, or we can say there are power outages for few hours. Then we can implement this type of solutions that will help us to maintain temperature and that will help to maintain the integrity of that product. So how the PCMs are significant in refrigeration? The significance of mass concept in refrigeration, excess freezer and cold rooms, is multi-factored. It depends on the multiple points. Some of the key points which are highlighted, which I am going to highlight here, like by using the fashion material, first we enhance the cooling efficiency. How can we enhance the cooling efficiency? Yes, mass effect allows for effective heat absorption during the refrigeration cycle, as I told earlier, which enables the cooling efficiency of system, ensuring the desired temperature are maintained within the minimal uses of energy. Second, we get the energy saving. If we use the PCM in refrigeration system, that will reduce the consumption of energy. That's how we can save the energy and lead to the lower electricity bills and operational costs. Next is we can reduce the cost by integrating or by using the fashion materials. Efficient refrigeration system incur lower operational cost because whenever we save the energy, that means we are reducing the cost or we are saving the cost due to reduced energy use. And this effectiveness is a crucial factor for business applications in the refrigeration industry. Next, one more point of which is have been achieved by using the fashion materials like sustainability. If we use the efficient refrigeration technologies that leverages lower mass, sorry, one second. Leverages the mass effect principle, reduce the greenhouse gas emissions and supports environmental sustainability. That means we are consuming less energy, we are burning less energy, that will save our environment, we are producing less greenhouse gas emissions to the environment. So that's how we can maintain the sustainability. That is the motto of our government. We have to reduce our conventional energy sources, we have to reduce the power cuts, and we have to depend on the renewable energies or clean energies. So that's how if we integrate the fission material with the existing cold rooms, or then we can reduce the energy consumption and we can maintain the sustainability. So it will help to improve, it will help to increase the growth of our country in terms of energy saving. Right. So how can we integrate the fashion materials? Like cold rooms are operated at different temperature ranges as per their product need. So that to maintain this temperature range, we have to go for different variations of fashion materials. Generally, in previous 4 days discussions, you all already knows about the fashion materials, how they will operate, how they will function. So generally, I'm again explaining the concept like fashion material is a substance that stores the energy at the time of freezing and it will deliver the energy at the time of melting. So for operation of cold rooms to store the different types of products, we have to operate with different ranges of with different temperature ranges of PCMs. Like in refrigeration and cooling, generally temperature ranges are varies for PCM in -20 to -5 degrees centigrade. In heating and cooling in buildings, generally temperature range varies from 5 to 40 degrees centigrade. In solar heating and electronics, where our aim is to generate the steam or preheated water, where temperature range varies from 40 to 80 degrees centigrade. And high heat recovery applications, where our aim is to recover the waste heat by using concentrated solar power, where temperature ranges varies in between 80 to 1200 degrees centigrade. For the majority of applications, PCM solution has to be encapsulated in sealed containers or any pouches or in tabs for to integrate in cold rooms or in chest freezers or in building applications. At Plus, we are encapsulating the fashion materials in different modes. Like we are also encapsulating the fashion material in tabs form, rectangular tabs form, or in micro microns thin layer filmed pouches, or in spherical stainless steel balls, or any other type of encapsulations we have. So, what are the innovations in technology we have observed? If we fill the PCM in pouches, it will give us the flexibility to integrate it in refrigeration systems like in chest freezers or in cold rooms, or also it will give the strength, durability, flexibility, and lightweight characteristics. If we fill the PCM in tabs, they will all they are generally made of the STP plastics, and the PCM filled tabs are ensure the leak-proof encapsulation, and they will easily integrate to the walls of the cold room or to the walls of the chest freezers and at the ceiling of the roof in building applications. So that's how we can, these are the innovations in technology where PCMs are encapsulated in different forms for their applications. Next, if we want to compare these encapsulation of PCMs, so in form factor, if we fill the PCM in pouches, it will give us the flexibility, adaptable to various shapes. We can modify or we can draw, fill the PCM in different types of shapes, which type of shape or which type of surface area we want to cover. And if we fill the PCM in tabs, then they are rigid, uniform shapes. And if we talk about in terms of thermal performance, so microencapsulation gives the flexibility and they are performing very well. Or in terms of tabs, they by using the highly conductive HDP plastic, their thermal conductivity will enhance, so they will also help in thermal performance. Encapsulation method, by filling the PCM in pouches, we get the maximum surface area to exchange the heat. Or if we fill the PCM in tabs, then there is a solid encapsulation. It will increase the durability, also increase the surface area. If we are talking in terms of ease of integration, so pouches can be easily integrated into the existing systems. Any type of, like, we don't have to modify the system. And if we talk about the plastic, then they are standard size and they are uniform. They can be used at large surface area like in cold rooms. If we're talking about the cost efficiency, potentially pouches have lower production cost, but PCM are initially high in cost, but their life cycle is very long. So they can be used for number of years. If we are talking about sustainability, then pouches are biodegradable and have recyclable plastics. So by using these two forms of encapsulation, we can achieve sustainability, or these encapsulation methods are also sustainable solution. So now we are talking about, okay, why we need PCM. If anyone says that my refrigeration cycle is running, why we have to modify, why we have to integrate PCM in cold rooms or in chest freezers? Because we have facing many challenges in the cold rooms. Like first is high insurance premium for the product stored in the room. Or why it is high insurance premium? Because the electricity cost is high day by day increasing. So cold rooms are charging much unit price to store the product. Next is unexpected spike in heat ingress due to fluctuations in the environmental conditions and frequent opening and closing just to store and to release the products. and just breakdown of the system. Maybe types of breakdowns can be occurred in cooled rooms that will also hamper the integrity and of the product and the part load efficiency of the refrigeration system, because we already know the refrigeration systems are very low efficiency and their consumption is very high. So if we in- integrate the PCM, then we can sustain for longer duration with low refrigeration efficiency. We can also manage the breakdown of the system for a few hours. Suppose if the system gets filled for a few hours and PCM is there, so it will have to maintain the temperature of that product at the desired level, and that means at the same of time you can repair your system. Also, if you frequently open and close the door, there is a chance of increase of heat, particular heat. So whenever this heat is inhaled or entered into the cold room, it will increase the refrigeration capacity. So it will increase the load on the compressor. So if we want to remove these small ingress of heat, then or we can say to balance out ingress of heat, we can put the PCM. If PCM is there, whenever the extra heat during the opening and closing of door entered into the room, that extra heat balanced, or we can say absorbed by the stored PCM. So it will not affect the refrigeration capacity. It will not increase the load on the compressor. So that's how we can manage the energy saving. Or also similarly, we can tackle the extra spikes in the heat ingress. Or also, if we integrate the PCM, that means we save the energy. So the insurance premium cost of the cold rooms should be minimized. Now, how we can integrate the PCM in cold rooms? Like integration of PCM in form of taps within the cold room is a transformative approach, because cold room has a large space area. We cannot put the PCM in form of pouches or in form of blocks, because we need to exchange the heat at a particular constant rate in the ambient or in the cold room space. So we have to place the PCM in uniform manner. So taps are the very efficient option, or we can say very promoting professional option to integrate the PCM in cold rooms. By integrating the PCM taps at the wall surface of the cold room, we can maintain the optimal temperature condition. PCM functions by absorbing and releasing thermal energy during the phase transition, effectively stabilize the temperature in the cold storage environment. So this is just a basic dimension of this cold room, where the PCM are placed in at the top of the roof or in form of taps. So that's how we can integrate the PCM in cold rooms, or it will help to maintain the stabilized temperature during, as I said, during the heat ingress, frequent opening and closing of doors, or due to the power shortage, outages of power, or maybe the failure of a refrigeration system for a few hours. Then in all these conditions, we can maintain the space temperature. We can save our product. Then next, what is important when we are integrating the phase change material in cold rooms? First of all, when we integrate the phase change material in cold rooms, we need to cover the surface area very strategically, like as mentioned in this picture or in this image. We have to place the PCM in a staggered manner to the just close to the wall, so that whenever there is extra cold during the refrigeration cycle, they will absorb this cold uniformly throughout the entire wall. Because whenever there is a fluctuation in the temperature, So there are possibilities fluctuation may be arise due to one wall because there is continuous change in the environment at different positions because sun is moving from east to west. So sometimes sun is facing towards right wall, sometimes sun is facing towards right side wall. So there may be ingress of heat from particular wall. So we have to place the PCM in different walls strategically. So that's how we can manage to balance the or to stabilize the temperature and how to manage the temperature. So to manage the temperature, we have to place the sensors at different locations. So they will give us the reading whenever the PCM is charged or discharged, or whenever the heat ingress, how much amount of energy by which is stored PCM is balanced and which is released to balance the amount of heat that is ingressed from the particular wall. So that's how is the number of sensors at different locations that will observe or they will give us the data, ensure that every time there is a constant or we say stable temperature fluctuation at each and every wall. Next is PCM integration in buildings. As we know, the buildings need the refrigeration like is air conditioning for maintaining the low temperature or for maintaining a comfort temperature. But in many of the buildings, there are weekends where we switch off the refrigeration system or we can say air conditioner. But there are many types of building offices where there are some IT equipments like so to maintain these IT equipment, there are IT server rooms. They are constantly running. They are extracting. They are releasing the heat continuously. So by this heat, the temperature of that particular environment goes on. Or for maintaining the or to ensure the perfect working of these server rooms, we have to maintain their temperature to a particular limit. So how can we maintain the temperature without running the air conditioner? So whenever we switch off or turn off the air conditioning during the Saturdays and Sundays days off, there by integrating the phase change material, we can maintain the temperature. Here within the server rooms, we can place the we can strategically place the phase change material in form of blocks or tabs. And during the working days like Monday to Friday, the PCM will charge. It will store the energy. Whenever we during the week off, we switch off the air conditioning system, then the continuous dissipation of heat from the server room equipments that will encountered by the stored PCM. So that's how we can manage the stable temperature inside the server room that will improve the functioning of the components or the instruments that are used in the server room. Or also the same concept can be applied for power outages times whenever there is power outages in the building and your ECs are switched off, then you have to maintain the temperature for the human comfort up to a level like so there we can integrate the PCM in the ceiling of the roof like as mentioned in this picture. So that integrated PCM during the running time of the refrigeration cycle absorb the extra heat whenever there is power out. It will help to maintain the temperature of that room. That's how we can maintain the stable temperature in buildings. There are many more applications in buildings like if we want to in cold regions like in European countries, if you want to maintain the hot environment or to maintain a comfort environment, then we can integrate the higher temperature PCMs. Whenever we run the heat pumps or room heaters, they will absorb the extra heat. And whenever there is a off time of refrigeration heat pumps or we can say heaters, then this PCM can balance that extra cold. So we can manage by using the PCM both side of either in cooling side or in heating side thermal management by placing strategically the PCM in buildings. So nowadays it is getting promoted very highly in European countries where the they are moving towards the achieving the sustainable goals. So they are lessly dependent on the electricity. So their aim is to cut off the consumption of electricity. And because we all are known with the fact that the electricity, or we can say energy consumption, is increasing day by day, or it will create the energy crisis. So every country is focusing on to save the energy. How can they save the energy? So to save the energy, you have to cut off the energy consumption. So how do you cut off the energy consumption? So there are a number of applications where we can integrate the fashion material, like buildings is one of them, because almost if we, according to a report of the World Energy Outlook, the total energy consumption of our country, 30%, the total amount of energy consumption of our country, and it's 30% is generally consumed in the building construction, building applications like to running the lights, to maintaining the temperature by running the refrigeration system, conditioning, heat pumps. So if we integrate the fashion material, then we can save the energy, we can reduce the energy consumption. So that's how PCM is becoming very important nowadays for building applications, where we can strategically use the PCM and reduce our energy consumption in building. Next, I'm talking about the integration of fashion material in chest freezers. Everybody familiar with the chest freezers. So this is one of the most important aspect, that how can we, without disturbing the design or without doing any major modification in the chest freezer, if we place the PCM in the chest freezer, and we can obtain the energy efficiency, we can reduce the energy consumption, we can save the cost, or it will be very helpful for the day-to-day work, operational day-to-day operation of the chest freezers, like in dairy milk product industry or in some stores, grocery store, where they have the chest freezers and they operate the chest freezers day and night, and they put the different types of products in these chest freezers. If we put the PCMs in these chest freezers and we reduce the consumption of energy, then we can save a lot of energy. So to check the integrity or validation of this project, at Plus we have conducted a case study. We have conducted an experiment where we have placed the face change material in form of pouches at the inner walls of the PCM, at the inner walls of the chest freezer, and we conduct the experiment. So I'm going to explain just the basic of this experiment. Okay, how can we put the PCM? As you can see from this figure, one is conventional, where there is no PCM, and another image is showing where we have integrated the fashion material in form of pouches around the surface walls of the chest freezers. And to put an extra support, we have placed a aluminum mesh for the integrity of these pouches, and we conduct the experiment. First, we conduct the experiment where we don't open the door and we don't open it, and we don't place any kind of product inside the chest freezer. So we have conducted this experiment and we get some results. So you might be very interesting, show your interest by knowing that whenever we place the PCM, we save the energy, we have reduced the compressor running time, and it will help us to save extra amount of energy. So I'm just showing the results. These are just the placement of the pouches. I'm just showing the results. Whenever we calculate the energy efficiency in terms of saving, we get the 15 units of energy saving per month by placing the fashion material in form of pouches in the chest freezers. So that's how we can manage the energy saving and reduce the energy consumption. So now it is very important for everyone. Okay, if they use the fashion material in their products like running refrigeration systems, chest freezers, cool rooms, or in building applications, the PCM will definitely reduce the cost. So PCM is very viable option for passive thermal management. And now, if we quickly summarize or we can conclude this session, so overall conclusion of this session is okay, PCM plays a very important role in building applications in cold rooms and in refrigeration systems. And as we know, refrigeration system and buildings thermal management is very important part or a very important part in respect to the energy consumption because these are nowadays energy consumption in refrigeration to maintain the human comfort and in building applications increasing day by day because buildings are increasing, the refrigeration industry is growing faster, and everybody is investing in them. So if we use the fashion material, if we provide the passive thermal management solutions to these industries, then these industries will reduce the consumption of energy, save the energy, and it will help to in the progress of our country. So that's all. Now, if anybody interested in any kind of questions or any kind of ideas, so he can ask. Thank you.
Thank you, sir. Thank you very much for a wonderful and informative session. And I request our participants to post questions if they have any query or clarification in the topic. So, dear participants, kindly unmute your mic. You can ask your questions or clarification required to the expert. Sir is ready to take up your questions. If you have any questions, kindly unmute your mic and ask the question.
Please ask if anybody want to ask anything regarding the fashion materials and their uses in building applications or in refrigeration industry. And if anybody want to do some kind of projects in their degree or in diploma or in like any research activity. So if they want any kind of support, if they want to understand something related to fashion material and their application, so they can ask.
I'll ask a question, Dr. Sudhir. This is Winston. I'm actually part of a Plus team as well in Dubai. One is on the mass effect, there's a lot of opportunities I can see because number of cold rooms are many. How to be commercially successful, what should we do next? Where to attend, where to go, if you have some thoughts and ideas on that.
Okay, like as we have managed to prove the concept that if we integrate the PCM like in refrigeration or in building or in pharma or in other industry, we save the cost, we get the energy saving. So this is a proven concept. Nowadays, first we have to educate the people, we have to reach out our reach to each and every we can say industry, or we can say to the common people, to the common MSMEs, regular small industries or small day-to-day work, technical grocery stores and any other small businesses where they have used the energy consumption in like refrigeration or in pharmaceutical components or in foods or in agriculture. So we can pitch our solutions to them and we can increase our reach to the customers. So they will understand okay, how can we save the energy. It will help us to maintain the sustainability of our country, and it will help us to achieve the sustainable goals. And when, how much energy we will save, it will help us for in coming generations to maintain the don't go, sorry, we can say it will help us to maintain the energy crisis nowadays world is facing. So that's how by educating people, by increasing our reach, or and also by increasing conceptually the efficiency, or we can say strategically, we can if increase the efficiency of our solutions, then we can pitch out the solutions to different customers or different industries, and then we can save the energy. So that's how we can increase our business, or we can say the business of this PCM industry.
Thank you, Doctor.
Anyone else want to ask?
Dear participants, if you have any query, kindly post your question.
Hello, hi, I'm Shaji. I
Yeah.
would like to ask one question regarding. So when in case we're adding some PCM in the chest freezer or something, so will
Right.
it add to the initial power consumption? Because by default the PCM is a load, right?
Right. Initially, it
When you start
increase
using the
the
PCM initially,
initially it will increase the power consumption, but we have to balance out it. Initially, it will increase the power consumption, but when it get a stabilized condition, suppose we cannot count the energy efficiency in form of day or hour. If we take a bigger picture, if we put the PCM initially, it will consume more power. When it will stabilize at certain point, it will a point is come that is called break even after 5 days, 15 days, or 10 days. After that, we start saving energy. So that's how we manage the energy efficiency.
okay. So one more doubt regarding that also. So in case I would like to maintain, for example, -10 in my freezer and in my chest freezer, what is the desired PCM or what type of PCM is to be selected based on the temperature range?
Yeah, for that we have different temperature, PCM temperature. And suppose if we want to generally refrigerators, temperatures are operated in -18 to -20 degrees centigrade, because this temperature is suitable for like most of the product. And generally, if we're talking in terms of ice cream or any ice related product, so for that, we have to select very strategically the PCM, like we can opt for the minus negative temperature PCMs, like we have HS -18 and HS -23. And so these PCMs can be integrated with the refrigeration. Those are suitable within the fitted range of refrigeration, or we can say that refrigeration temperature. So whenever the refrigeration is turned on, they will absorb the extra cold, and whenever there is a power outages, or we can say there is a, and we can say whenever there is a kick in, kick off the compressor, so it will stabilize the temperature for longer duration. So it will reduce the kick in, kick off of the compressor, and it will reduce the compressor running time. So that's how we can save the energy. Whenever compressor kick in or kick off, kick start, the energy consumption is slightly high. So if we reduce the frequency of compressor for turn on and turn off, then we can also save the, like we can increase the life cycle of the compressor also. So overall, in terms of by increasing the life cycle of compressor, by stabilizing the temperature, or in terms of if there is any power outages, like in rural areas, if there is one general store person has a chest freezer, and if he places the patient material and there are some power outages for few hours, then he can manage to get the integrity of the product for that duration. Again, electricity will come and the refrigeration cycle will continue from that point. So that's how we can manage. Anyone else?
Participants, if you have any query? Thank you, sir. Thank you, sir. I think
Thank you thank you
someone
everyone for your love.
raise their hand. If you have any very kindly unmute your mic and ask. Dr. Karka Satyanarani and Vishwajit Bera, you raise your hand. If you have any query, you can unmute your mic and ask the speaker.
No, sir, no, I don't have any. Thank you, thank you.
Ma'am, it's not audible. Or you can post in the chat box if you have any query, ma'am.
Yeah, you can put your query in chat box also.
Okay, so thank. I think they unintentionally hit that hand raising button, sir. I think there is no more queries or questions from the participants. Dear participants, this is the last session of 5 days online BP. We have some formalities to be completed. Kindly be in the meeting link. So let me first express our thanks to the Plus Advanced Technology for coming forward to organize this 1 week industrial FDP to our participants. On behalf of Murugappa Polytechnic College and on behalf of the Department of Mechanical Engineering, I extend our sincere thanks to Mr. Samit Singh, who is the MD of Plus Advanced Technology, and Mr. Praveen Das, Vice President, and Mr. Vishnu Sashidharan, Vice President, and Mrs. Nidhi Agarwal, Head R&D. Also, the fine expert speakers for all the 5 days, Mr. Amar Ratan, Mr. Raman Chauhan, Mr. Bhunesh Kumar, and Mr. Ramnath Satpude. And today we have Dr. Sudhir Pathak. They are all spared their valuable time with us. They delivered a wonderful session, informative session. I think all the participants found the sessions very useful and informative. So on behalf of all the participants and on behalf of Murugappa Polytechnic College and on behalf of the Department of Mechanical and my own behalf, we extend our sincere thanks and request Dr. Sudhir Pathak to convey our wishes and thanks to the entire Plus team. Thank you,
Yeah,
sir.
sure.
Thank you very much.
Thank you.
Okay, so before going for the final feedback, I request all the participants to switch on their camera and we can have a screenshot session for our records. I request all to switch on your camera. And if you have any feedback to tell about the FDP, you can switch on your mic and tell also. That we will have after the screenshot session. I request all to switch on your camera and post for 2 minutes for getting some screenshots. So dear participants, switch on your video camera. You can have a screenshot. So dear participants, switch on your camera. You will have a screenshot. Thank you all. Dear participant, if you have anything to say about the FDP, if you want to give some feedback, you can switch on your mic and you can inform your feedback. There is a formal feedback link. We will be in the chat box. You can say that. If anything you want to say about the FDP, you can switch on your mic and you can say your feedback. So thank you all. Thank you, Sudhir Pathak sir. Thank you for joining with us today. Can we our plus team?
Yeah, sure.
Thank you, sir.
Thank you. Thank you.
So dear participant, be on the meeting link. Our people will share the feedback link. Thank you.
Thank you, sir.
So, sir, can I leave?
Yes, sir. Yes, sir. Please, sir.
Okay, thank you.
Thank you, sir.